Hi, everyone. This is John Bateman from NOAA Satellites Public Affairs. The GOES-U media briefing will begin shortly. We are just giving everyone a couple more minutes to join the briefing, and we will then start. All right. Good morning, everyone, and thank you for joining this virtual media briefing for the upcoming launch and historic mission of NOAA's GOES-U satellite. I'm John Bateman with NOAA Communications, and I'll be facilitating today's briefing. If you have additional questions after the conclusion of the briefing, my colleague John Leslie and I can both be reached by email at nesdis.pa@noaa.gov. Today's briefing will feature a short introductory video highlighting the GOES-U satellite and its journey to Florida for final preparations before launch. Then experts from NOAA, NASA, Lockheed Martin, and L3Harris will provide their perspectives on the technology and partnerships that are critical to this mission, as well as discuss the benefits GOES-U will provide once in operation. Lastly, our experts will be on hand to answer questions from members of the working media during our Q&A session after the presentations. GOES-U is scheduled to lift off on June 25th at 5:16 p.m. Eastern Daylight Time aboard a SpaceX Falcon Heavy rocket from NASA's Kennedy Space Center in Florida. Once in orbit, GOES-U will be renamed GOES-19. After checkout of its instruments, systems, and data, GOES-U will replace GOES-16 in the GOES East position and will monitor much of the Western Hemisphere. Before we get to the presentations, we are going to show a short video that will give everyone an idea of the teamwork it takes to ship a satellite that is the size of a small school bus from its home in Littleton, Colorado, to NASA's Kennedy Space Center. right. And with that, I will introduce our experts today. First is Irene Parker, Deputy Assistant Administrator for Systems at NOAA's Satellite and Information Service. Our second presenter is Pam Sullivan, Director of NOAA's Geostationary Earth Orbit Observations Office. Next will be Dan Lindsey, Program Scientist for NOAA's GOES-R program. Then we'll hear from Jordan Gerth, a meteorologist from the NOAA National Weather Service Office of Observations. Following Jordan, the Director of NOAA's Office of Space Weather Observations, Elsayed Talaat, will also speak. Our next presenter will then be John Gagosian, Director of NASA's Joint Agency Satellite Division. Then we'll hear from John Diley, GOES-R Flight Project Manager at NASA Goddard Space Flight Center. After John, we'll hear from Jagdeep Shergill, the GOES-U Program Manager from Lockheed Martin. Following Jagdeep will be Chris Reith, Advanced Baseline Imager Program Manager at L3Harris Technologies. And finally, we'll hear from Rex Engelhardt, GOES-U Mission Manager from NASA's Launch Services Program. We will now kick off our presentations with Irene Parker from NOAA. Irene?
Thank you, John, and good morning, everyone. We're just a few weeks away from the launch of the NOAA's GOES-U, the last and the best of the satellites in the GOES-R series. There are three key reasons that make this an historic mission. First, GOES-U is the last satellite in the GOES-R series, which sent the most advanced Earth monitoring technologies ever flown in space when we launched GOES-16 in 2016. You'll hear more from Jordan Gerth about how this event changed the game for weather prediction. GOES-U is also historic because it will carry the first ever operational compact coronagraph called the CCOR-1 that will significantly improve NOAA's ability to monitor the sun and forecast potentially harmful space weather events. Dr. Elsayed Talaat will give us more detail on this. But probably the most important reason GOES-U is historic is because it is the bridge that connects today's geostationary satellite technology with the technology of tomorrow's that's even more sophisticated, more impactful than what the GOES-R satellite series currently provides. We are working closely with Congress to fund the Geostationary Extended Observations, otherwise known as GeoXO satellite system, so that it's operational in the early 2030 timeframe. GeoXO will feature a suite of instrumentation that provides continuity to the GOES mission and introduces new measurements in sounding, ocean color, and atmospheric composition. Pam Sullivan will highlight this more. While it's important to remember GOES-U is a NOAA mission, it's also critical to note, just like with each of the previous satellites in the GOES-R series, our partner NASA has played a key role in bringing the satellite to the launch pad. In fact, the NOAA-NASA partnership has successfully sent many environmental satellites into orbit during the last 50+ years, and we're delighted to have John Gagosian from NASA's Jagdeep here. The launch of the GOES-U underscores NOAA's commitment to putting the best technology in space to monitor weather, water, climate, and the sun with unparalleled accuracy and timeliness. With that, I turn it over to Pam Sullivan. Thank you, and go GOES-U.
Thanks, Irene, and thanks everyone for joining us this morning. NOAA's geostationary satellites are an indispensable tool for protecting the United States and the 1 billion people who live and work in the Americas. They provide a constant, real-time view of weather and dangerous environmental phenomena across the Western Hemisphere. GOES-U is the fourth and final satellite in the GOES-R series, which is NOAA's current generation observing system. The GOES-R satellites have brought amazing new technology to help forecasters better monitor hazardous weather conditions like hurricanes, thunderstorms, floods, and fires. The main camera on the GOES-R satellite scans the Earth disk every 10 minutes and can zoom in to track dangerous storms with 30-second updates. The satellites also include a lightning camera that takes pictures of the Earth 500 times a second to track lightning to help identify severe storms likely to spawn tornadoes, hail, or damaging winds. GOES-U was developed by a team of people from NOAA, NASA, industry, and academia. It continues the decades-long NOAA-NASA partnership to get the best technology into space for accurate, up-to-the-minute forecasts and for long-term climate monitoring. GOES-U is part of a multi-generational family that began with the first geostationary weather satellite in 1975, and it will continue operation into the 2030s. To ensure these critical observations continue after that, NOAA is now developing its 6th generation geostationary observing system called GeoXO. GeoXO will have advanced instruments that provide an order of magnitude more data than GOES-R. These include an imager with improved spatial resolution for more precise tracking of storms and fires, an ocean color sensor to monitor water quality and hazards, and atmospheric sensors to track air pollution and improve local nowcasting. GeoXO capabilities will help us address the challenges of a changing planet, from more unpredictable weather to more prevalent harmful algal blooms to more widespread wildfires. GeoXO implementation is now underway with 4 of the 6 satellite development teams in place. As we prepare for the launch of the final GOES-R satellite next month, we are already working to have the first GeoXO satellite ready for launch in 2032 in order to ensure the continuity of these critical observations. Next, I'll pass it to our GOES-R program scientist, Dr. Dan Lindsey.
Thank you, Pam. Good morning, everybody. GOES-U will be the 4th and final GOES-R series spacecraft. It carries the same complement of 6 instruments that GOES 16, 17, and 18 had, except with a 7th, as has already been mentioned, known as the compact coronagraph, and it's there to monitor the outer region of the sun. As has been mentioned by Pam, the primary camera on board is called the Advanced Baseline Imager. It's a visible and infrared camera and provides continuous monitoring of hurricanes, severe storms, and really lots of different hazards on the Earth. The Geostationary Lightning Mapper, or GLM, is the 2nd Earth-pointing instrument on board. It is, for the first time with GOES 16, it allows us to have continuous view of convective storms across the entire globe. Across the entire hemisphere, so we can do things like have pilots steer away from those convective storms that happen to be producing lightning. The rest of the instruments are focused on space weather. One of them is called the Solar Ultraviolet Imager, or SUVI. It takes photos of the sun in the ultraviolet. We are approaching now the peak in the solar cycle, and there's really been a ramp up of solar activity. So having these sun pointing instruments is really important. The next is called the Space Environment In Situ Suite, or SEIS. It detects energetic particles that can be harmful to satellites and even our astronauts on the space station. The Extreme Ultraviolet and X-ray Irradiance sensors detect solar flares. We have a magnetometer that measures the magnetic field surrounding the Earth. And then the 7th and the new instrument on board, again, is the compact coronagraph. It'll help detect and forecast coronal mass ejections. Elsayed is going to be talking with a little more detail about the C-core in just a few minutes. In its GOES East position, perhaps the most important aspect that GOES-U, which will become GOES 19, will be to detect and track hurricanes. With its advanced baseline imager, it can zoom into the eye of the storm and get a latitude-longitude position. It can get a directional heading as well as an estimate of the storm's intensity. That information is then fed into the forecast models that tell the forecasters where the storm is going to go in 3 days, 5 days, or 7 days. And that way they can warn the public. Say if the storm is headed for eastern Florida, they can ask the residents there to take precautions and perhaps evacuate. I think maybe the biggest game-changing aspect of the entire GOES-R series is probably the ABI's ability to detect wildfires. We knew it could detect fires, of course, but it's able to do this in a much more impressive way than we foresaw. For example, we had an example of the GOES East ABI detecting a fire the size of a small barn. So very small types of fires. This is important because it allows us to get the word out to emergency responders, firefighters, and take care of those fires as quickly as possible. Pam mentioned GeoXO. The GXI on GeoXO, the new imager, will have 4 times better spatial resolution for its fire detection band, and that really truly will be game-changing. With that, I'll pass it over to Dr. Jordan Gerth from NOAA's National Weather Service.
Good morning, everybody. I'm Jordan Gerth, the NOAA National Weather Service meteorologist overseeing the weather satellite observations that are available to more than 120 of our field offices nationwide. Simply put, GOES provides the most vital weather observations that enable our forecasters to monitor dangerous storms and other environmental conditions. The GOES-16 satellite currently goes east, and the GOES-18 west satellite support our meteorologists in meeting the NWS mission of saving lives and protecting property. I can't stress enough in any stronger language the importance of the GOES-R mission and the GOES-U satellite to the National Weather Service, or NWS. The NWS provides weather forecasts and warnings to an expansive geographic area that includes much of the northern Pacific Ocean, from Guam through Hawaii to the California coast, Alaska, south to American Samoa, the contiguous United States, and much of the northern Atlantic Ocean, from Africa to Puerto Rico, Florida, and the Gulf Coast. GOES-R collects regular imagery capturing the entire disk, the face of the Earth, viewable from its geostationary orbital position every 10 minutes. NWS meteorologists often request enhanced scanning of rapidly evolving storms and other phenomena, such as hurricanes, volcanic ash, and fires, as regularly as every 30 seconds to 1 minute. This May, we've had an active stretch of severe storms in the central, eastern, and southern United States. There have been over 720 tornadoes confirmed in April and May, placing it in the top 3 for those 2 months after only 2011 and 2019. Our offices in the National Weather Service have issued 1,921 tornado warnings since the beginning of the year as of noon yesterday. There have been 5,890 severe weather reports this month alone, the most in a month since 2011, and GOES has been with us every step of the way. Through the regular scanning of the GOES-R Advanced Baseline Imager, or ABI, which will also fly on GOES-U, meteorologists at our Storm Prediction Center are able to issue severe thunderstorm and tornado watches as soon as it becomes apparent that the cumulus clouds are expanding and growing vertically. As clouds grow, they cool, and the ABI is able to sense those subtle changes in cloud top temperature. Research has shown that clouds that cool faster have a greater likelihood of becoming severe, causing damage and endangering lives through intense hail, wind, and even tornadoes. For mature storms, such as supercells, NWS meteorologists are able to use the Geostationary Lightning Mapper, or GLM, to monitor trends in lightning as an additional indicator of storm severity. The National Weather Service mission also includes space weather, and it's been a busy month for that phenomena as well. There's been renewed public interest following the strongest geomagnetic storm in over 2 decades, which occurred a few weeks ago. Multiple corona mass ejection produced a G5 storm, the highest category on NOAA's space weather scale, and of course there were impressive aurora displays. The Compact Coronagraph, or CCOR, is a new instrument for GOES-U that will detect the white light of the upper solar corona, the outer layer of the sun, and deliver imagery back to Earth for use at our Space Weather Prediction Center within 30 minutes. Thanks again for the opportunity to talk about how GOES helps the National Weather Service build a weather-ready nation. I'm extremely excited about the GOES-U launch and placing the data in the hands of our meteorologists by next spring. I look forward to your questions after my colleagues' remarks, and I'm passing it off to Dr. Elsayed Talaat.
Thank you, Jordan, and good morning, everyone. These past 2 months, we've had a remarkable opportunity to witness not one, but 2 cosmic masterpieces throughout the nation. The first being the Great Total Solar Eclipse, and more recently, the Aurora Borealis, otherwise known as the Northern Lights, reaching as far south as Florida for the first time in 20 years. Each of these celestial wonders gives us insight into our sun and its activity, called space weather. We are able to enjoy such beauty because of the proactive measures we take and the robust procedures in place to mitigate against the severe impacts of space weather, which can otherwise wreak havoc on our key infrastructure. For decades, NOAA has observed space weather to produce warnings, alerts, and forecasts so that industries can take action to mitigate potential disruptions in advance. This includes our communication systems, which are essential for emergency response efforts during national disasters, and for pilots to fly our planes safely with functioning navigation and communications. Even the GPS we use in our everyday lives is sensitive to space weather. For instance, during the recent solar storm, farmers across the country reported being unable to plant their crops because the precision GPS relied upon by their equipment had malfunctioned. In another instance, NOAA space weather warnings and alerts gave lead time for operators to take precautionary actions, for our power grid, such as voltage reduction and generation adjustments in order to avoid power outages. We must be vigilant in our space weather observations to protect our economy, national security, and individual safety. We are very excited for the launch of the GOES-U satellite, in part because it will carry the nation's first operational coronagraph, as you heard, called CCOR. This means for the first time, the US will have continuous observations of the sun's outer atmosphere, creating an equivalent of a total solar eclipse every 30 minutes. In doing so, this powerful solar telescope, which is part of NOAA's Space Weather Follow-On program, will allow us to observe the region where extreme space weather events originate, the sun's fainter outer atmosphere called the corona. The coronagraph, working in tandem with the magnetometers, the solar ultraviolet imagers, and extreme ultraviolet and X-ray radiance sensors that are on board GOES-U and GOES-18, that's going to be operating in the GOES West position, will strengthen NOAA's ability to predict space weather. They will see and sense the solar wind, solar flares, and coronal mass ejections that can send billions of tons of highly magnetized material hurtling towards Earth at several million miles an hour. This material, as we saw in the recent storms, causes geomagnetic effects, which can trigger widespread damage to electric power grids that power communities, as well as impact satellites, communications, and navigation systems. Once operational, CCOR will deliver imagery of coronal mass ejections to Earth within 30 minutes of taking the image in outer space. This is a vast improvement compared to our current system, which can take up to 8 hours to get data from the SOHO-LASCO instrument, which was launched back in 1995. The data will serve as a primary source of information about impending geomagnetic storm conditions, allowing NOAA's Space Weather Prediction Center to issue watches and warnings 1 to 4 days in advance. Although the sun is no more active than in previous generations, our society has changed. With our increasing reliance on electric power, global telecommunications, satellite navigation, and aviation, we are more sensitive than ever to the sun's changing mood. NOAA satellites are the backbone of our country's plan to become a space weather-ready nation. And we look forward to the GOES-U launch, getting us closer to the types of measurements we need on a continuous basis to be responsive and resilient to space weather events. Now I'll hand it off to John Gagosian from NASA. Thank you, and go GOES-U.
All right, thank you, Elsayed, and hello, everybody. I'm John Gagosian. I'm director of NASA's Joint Agency Satellite Division, and our division is part of NASA's Science Mission Directorate. We manage on NOAA's behalf the development and deployment of operational weather satellites like GOES-U. Our 5-decade partnership with NOAA has resulted in the successful operation of more than 60 satellites dedicated to weather forecasting, severe storm and hurricane prediction, and climate observations. We're very excited to complete the 4-satellite GOES-R series with the most capable geostationary weather satellite in our nation's history. NASA is responsible for the formulation, development, launch, and initial operation of the GOES-U satellite. Our team has incorporated many lessons learned from the previous 3 satellites in the GOES-R series. The team has been working diligently with our industry partners to be fully ready for our launch on June 25th. We're also proud to continue our NOAA-NASA partnership into the future as we move through the design phase of GeoXO, the system of geostationary satellites that we will deploy in the 2030s, as Pam described earlier. I'm proud that NOAA and NASA have collaborated so well over the life of the GOES-R program, and that we are poised for a very strong finish. And now I'll turn it over to John Diley.
Thank you, John. Good morning. I'm John Diley, the GOES-R Flight Project Manager. NASA Goddard Space Flight Center is responsible for the development of the GOES-R series satellites and instruments for NOAA. At Goddard, the flight project consists of an engineering and management team that leads the development and delivery of on orbit of these highly complex machines. Our team developed the specifications and requirements for the spacecraft and the instruments devised the methods to operate them in orbit, and then contracted with vendors to conduct various tasks associated with building and then testing each GOES instrument and spacecraft before it gets to Florida in preparation for launch. The plan from the beginning has been for the 4 GOES-R series spacecraft to be virtually the same model. But by now, of course, NOAA wants the best possible spacecraft, incorporating all the upgrades and lessons learned from the development and operation of the first 3 spacecraft. So this 4th spacecraft, GOES-U, while sibling to the first 3 spacecraft already in orbit, is unique. Our GOES-U team has taken advantage of all the experience gained and incorporated all the design process improvements derived from the first 3 builds to make this the best GOES satellite. In addition, changes in subcontractors like SpaceX, our new launch vehicle services provider, has required us to adjust how we process and fly the GOES mission. And on top of all of that, NOAA has asked us to incorporate the new instrumental GOES-U, as you've heard, the solar coronagraph called Compact Coronagraph CCOR. After implementing the necessary design modifications to accommodate and integrate CCOR, the instrument has been a full participant in the rigorous testing of the GOES-U satellite. CCOR is ready to become the first operational coronagraph in geosynchronous orbit and produce spectacular images of our sun's corona on a continual basis. To sum it up, NASA's GOES team works with NOAA to determine the requirements. We contract with companies such as Lockheed Martin and L3Harris to provide the satellite and the instruments, and we oversee their work. We also have the GOES-R mission operations support team that leads the checkout of the GOES-U satellite on orbit to make sure all the instruments and systems are working properly. Then we hand it over to NOAA for operations and provide engineering expertise throughout the life of the mission. GOES-U will be the most robust and most capable of the GOES-R series spacecraft and should provide NOAA valuable Earth and science data well into the 2030s. We're looking forward to a successful GOES-U launch. Next up is Jagdeep Shergill from Lockheed Martin.
Thanks, John. So as you saw in the intro video, on January 23rd, a police escort led the GOES-U spacecraft from our Lockheed Martin Littleton, Colorado facility to Buckley Space Force Base. The spacecraft then flew to Florida aboard the Lockheed Martin-built C-5 Super Galaxy air transport, arriving at the historic Space Shuttle landing strip. The spacecraft was then transported to Astrotech Space Operations in Titusville, Florida, where it has since undergone final preparations for launch, including spacecraft and instrument testing, propulsion testing, final closeouts, and fueling. And I'm happy to report that the spacecraft had no issues during these final preparations and is now fully ready for integration with the Falcon Heavy rocket. Like John talked about, throughout this GOES-R series, the Lockheed Martin engineering and operations team have worked meticulously to capture lessons learned and ensure corrective actions were applied from one spacecraft to the next. As such, GOES-U encountered the least number of issues through all of its integration and testing. And even while working on GOES-U through COVID, Lockheed Martin met every milestone on or ahead of schedule. And this is further illustrated by the addition of the Compact Coronagraph, built by the Naval Research Lab, that's unique to the instrument suite aboard GOES-U. We reworked our sun pointing platform to accommodate CCOR and successfully tested it throughout the spacecraft test campaign. In addition to designing and building the GOES spacecraft, Lockheed Martin also provides 2 of the other instruments on GOES, as Dan talked about. The first ever Geostationary Lightning Mapper, or GLM, as well as the Solar Ultraviolet Imager, or SUVI. This launch is truly the culmination of years of hard work by an enormous team of engineers from Lockheed Martin, NOAA, NASA, and countless other teams. We're so honored to help bring forecasters the data they need to save lives and property when it's needed the most. From launching the first ever weather satellite to building this current GOES-R series, we here at Lockheed Martin are passionate about supporting NOAA's mission, especially as climate change drives interruptions to our current weather patterns. And speaking of groundbreaking data, I'd like to hand it over to Chris Reith from L3Harris to talk more about the Advanced Baseline Imager.
Thank you, Jag, and good morning, everyone. L3Harris Technologies has been on the forefront of environmental sensing dating back to the very first instruments on NASA's Meteorological Research and Development spacecraft. Now here we are, nearly 60 years later, getting ready to launch GOES-U, the final GOES-R series satellite. Throughout this journey, L3Harris's next generation weather instruments and ground systems are forging a new era of preparedness. L3Harris provides the primary instrument on the GOES-U satellite, the Advanced Baseline Imager. We also provide the Enterprise ground system used for the GOES-R series, as well as the propulsion systems on the spacecraft. The Advanced Baseline Imager, or ABI, views the Earth with 16 different channels or colors, each channel measuring energy at different wavelengths along the electromagnetic spectrum to obtain information about the Earth's atmosphere, land, and oceans. Combining data from these channels in different ways allows meteorologists to highlight features of interest. ABI data is used for detecting and monitoring many different environmental hazards, such as severe weather, hurricanes, flooding, wildfires, smoke and ash from volcanic eruptions, and other threats. ABI provides a view of the entire hemisphere in as little as 5 minutes, with the ability to support coverage of extreme weather events with 30-second updates. The ABI instrument is designed and built in our facilities here in Fort Wayne, Indiana, with testing completed in our Rochester, New York facility. The L3Harris built Enterprise ground system provides command and control, data downlink, and product processing and distribution. This system converts raw satellite data into critical information for forecasters. In concert with the ground system, ABI has revolutionized predicting weather, putting information into the hands of meteorologists faster than ever before, making it a game changer for NOAA forecasters. The integration of L3Harris's technology into GOES-U will help protect individuals, communities, and property in the face of severe weather events, providing the information required for more accurate, timely, and detailed forecasts. From space to ground for nearly 60 years, L3Harris technology has supported NOAA's mission to protect lives, property, and the economy. We look forward to our continued partnership with NOAA, NASA, and our industry partners, serving to protect the lives and property of our nation's citizens. I'll now turn it over to Rex Engelhardt. Thank you.
Good morning, all. My name is Rex Engelhardt. I'm at Kennedy Space Center, and I'm the Launch Services Program Mission Manager for the GOES-U mission. Launch Services Program, for those of you who haven't heard what we do, we procure commercial rockets and integrate onto that rocket the satellite for almost all NASA uncrewed missions. My job as the mission manager is to lead the Launch Services Program team that does all that work. I get involved in reviewing proposals at the very beginning from different satellites that are looking for a ride to space. And then when the spacecraft is selected, I introduce myself, I do trade studies as required, I help them develop their launch vehicle requirements, as John was talking about. And then I'm the technical lead in procuring that rocket for them under a commercial contract that NASA uses called the NASA Launch Services #2 contract. We have the rocket on contract. After we have it on contract, I then head up a mission integration team that goes through the technical process of integrating the spacecraft and the rocket into a combined system. When they're flying together, everything's from performance, the mass of the satellite the rocket has to be able to support. We've got loads, we've got acoustics. We don't want the satellite to break the rocket. We also don't want the rocket to break the satellite. There's wiring. You got to make sure you have the correct wires, and then you got to make sure that the interface, the connectors match. We customize the rocket as required. We got to put in a purge, a GN2 purge for the instruments. We got fairing doors have to be in the correct locations. Contamination requirements have to match the requirements of the spacecraft. The rocket has to meet those requirements. We got ground processing. I have a team that goes out and procures a processing facility for the satellite so they can do the final part of their integration and test at the launch site. And then we start to get what we call integrated operations, where the rocket brings over the fairings, which is the part of the rocket that protects the satellite during ascent. And that equipment starts to come together. We There's integrators where we start putting the satellite onto the rocket components and buttoning it all up inside the fairing. That goes through moving out to the launch pad, and then we eventually hand off to a launch team, and everything, which takes it through launching them, and all the spacecraft and the integrated team bubbles up a commitment and ready to go for launch up to the Launch Services Program's mission director, who gives the final go for launch to the SpaceX team. I have done all this for GoSU, and it's been a lot of fun. I want to talk about schedule next, just to let you all know where we are in the processing. Currently, the spacecraft has finished most of its offline processing of getting ready for launch and being ready for meeting the launch vehicle. The spacecraft is fueled and ready to go. It'll be encapsulated on the 13th of June, and then it'll move out to the Complex 39, where one of the shuttle pads used to be. It's now used by the Falcon Heavy rocket on the 14th. And we'll perform some final spacecraft testing and configuration out there, and at which time we'll be ready to mate what we'll call it an encapsulated assembly, which will be the satellite inside the fairing. That'll be mated to the Falcon Heavy rocket on the 22nd of June. We'll roll the Falcon Heavy up with the spacecraft on it up to the launch pad on the 23rd, and then the launch will be on the 25th at 5:16 in the afternoon. Technically, we have a 2-hour launch window that we can use for trying to dodge weather or something like that. But as we all know, when you get into operations like this, schedule is subject to change. So it'll be close to that. Flight timeline, just to let you know a little bit more what to expect on launch day. As I mentioned before, we'll launch at 5:16, and which is the front of that 2-hour window. At about 2 minutes and 24 seconds into flight, the two side boosters will cut off, and they'll separate and start a flight home for reuse. At 3 minutes and 58 seconds, the center core booster will shut off. It separates and then drops into the ocean. At about 4 minutes and 16 seconds into flight, those protective fairings that I talked about that have been protecting the satellite from the wind and the atmosphere on the way up the hill, they will separate and drop off. And then we'll kind of burn, and we'll start there's several burns of the second stage. It starts and stops about 3 times over roughly a 4-hour and 20-minute flight. And then at 4 hours and 30 minutes, the GoSU will separate from the Falcon Heavy. And then just to kind of complete things and make sure everything's right, at about 4 minutes and 47 seconds, the first step of the solar array deployment will happen, and we'll get telemetry back from the satellite that tells us that we're power positive and we have a successful mission. That is all I have.
All right. Thanks so much, Rex. All right. Now is the time for you guys to be able to ask our experts a question. To do that, please find the Q&A box located at the bottom of your screen. Could you please type in your name, affiliation, your question, and the specific expert who would like to answer your question if possible. Again, we will now take questions from the working media. Just put it in the box, the Q&A box at the bottom of your screen. Looks like we have one already. Our first question appears to be for the director of NOAA's Office of Space Weather Observations, Elsayed Talaat. Elsayed, the question is, with all of the space weather and geomagnetic storms that have been impacting us lately, what information will the compact chronograph instrument on GoSU provide that we don't currently get from GOES satellites?
So thank you, John. As I mentioned, the GoSU is going to carry the nation's first operational chronograph, and it's going to be a great addition to the space weather suite of instruments on the other GOES satellites. This is a powerful instrument that can measure the outer atmosphere of the sun, called the corona, where extreme space weather events originate. And it does this by blocking the disk of the sun, creating a total solar eclipse every 30 minutes. And that allows us to observe large explosions off the sun, called coronal mass ejections, that can hurtle billions of tons of matter at millions of miles per hour towards Earth. And these type of observations are key to our long-range forecasts in space weather. So they give us 1 to 4 days worth of warning before they reach Earth here and cause geomagnetic storms and potential impacts on human life and critical technologies. And so that's what's new on the GOES-U satellite. That's going to replace our aging infrastructure, research infrastructure that can take up to 8 hours for us to get those measurements. So now we'll have them continuously.
All right, thanks so much, Elsayed. We have another question. It says, hi, Meredith Garofalo from space.com and Rocket Girl Enterprise LLC. This can be for whoever thinks they might be able to best answer it. I can answer the last part of it, though. The question is, what will make this launch different, having a Falcon Heavy rocket as opposed to an Atlas V, as we saw with GOES-T? Why Falcon Heavy, and how will the public be able to watch the launch? Meredith and everyone else, for the last part, the launch will be streamed live on NESDIS's website and carried live on NASA TV, so you can check it out at both locations. As for the rest of it, why are we having a Falcon Heavy as opposed to the Atlas V? Who would like to take that question?
This is Rex. I can take it. I think John might want to weigh in on this too. Well, Falcon Heavy Launch Services Program, our contract has multiple rockets on it, and we try to keep that open so we have competition, which is always helpful for protecting the government's dollars. So Falcon Heavy and Atlas were both capable of meeting this mission. We chose the Falcon Heavy in this case. It does offer a little bit more performance. It has a different way of processing. The Falcon Heavy processes horizontally versus vertically for the final part of the integration period. Other than that, both are going to be successful. We've had some challenges. The new rocket has got a different way of doing business, and John and I have worked together for a couple of years to sort that out and make it work. But other than that, they're both going to get us where we need to go. John, do you have anything you want to add to that?
Yes, thanks, Rex. I guess the one thing that I would say is between Rex's team at the Launch Services Project with JAG's Lockheed Martin team and our team here at Goddard, we've done our darndest to make the differences as small as possible to not upset the apple cart with our GOES-U satellite. So we've done as much as we can to make it identical, but it's not. But we've done our darndest to make it as smooth and painless the transition as possible.
All right. Thanks so much to both of you. Our next question comes from Marcia Smith from spacepolicyonline.com. This is for Elsayed again. To what extent does Seacor 1 replace capabilities on the aging space weather satellites at Sun Earth L1? Do we need L1 satellites anymore for space weather warnings?
We absolutely do. The compact chronograph gives us, as I mentioned, looks for these explosions off the sun, and it's the key input to the models that can tell us if it's coming towards Earth or not. But we need that upstream buoy measurements that L1 satellites can provide. So those measurements tell us what the solar wind that is actually coming towards Earth. So basically the tide that's coming or the wave that's coming towards Earth, and how geoeffective it's going to be, how much of an impact it's going to have here on Earth. So that gives us 15 minutes to a couple hours warning to our stakeholders like the power grid and civil aviation of how bad the storm is going to be, and whether if it actually reaches, or what time it actually reaches Earth. So that's why we're planning a space weather follow-on L1 mission that's going to fly, that's going to launch next year in 2025 to succeed the Discover satellite, the NOAA Discover satellite, to continue those upstream buoy measurements that we have there. And it's also going to fly a copy of, or a sister instrument, a chronograph, another compact chronograph, Seacor 2. And so that way we add resilience to the system for the measurements we need for long-term forecasts, and have an unobstructed view of the sun from L1, a continuous unobstructed view there. So we both need the in-place in situ measurements at L1 and at geostationary, as well as the remote sensing measurements that we're going to get from geostationary.
All right, thank you, Elsayed. Next one looks like this could be for Jordan Gerth. We have a question from Jenny Stiletovich. I hope I'm pronouncing that correctly. Jenny is from WLRN Public Radio in Miami. The Atlantic hurricane season officially begins this weekend. How soon will the new GOES begin providing information on tropical systems? And can you talk a little more about the advances that GOES-U will provide in forecasting? Thank you.
Yeah, thank you, Jenny, for that question. The Atlantic hurricane season, NOAA is forecasting it to be quite busy. I'm sure folks in Miami and along the coast know that the sea surface temperatures are higher than normal, and that is going to provide fuel for what is unfortunately going to be a busy hurricane season in all likelihood. GOES is with us every step of the way. We have GOES capabilities, GOES-R capabilities in orbit currently. So that GOES-16, that east satellite, as far as the weather instruments go, the advanced baseline imager, which is providing the imagery, and the geostationary lightning mapper are going to be ready for this tropical storm season, this hurricane season, as it has been in the past few years. GOES-U will be replacing that satellite in the spring, most likely early April of next year. And so it will be ready for next year's hurricane season. But again, the GOES-R series satellites, whether that's GOES-16 up there currently or GOES-U, which we'll be launching, is going to be able to provide our forecasters at the National Hurricane Center imagery as frequently as every 30 seconds if they need it. And that has been a vital step with this mission, with this series of satellites, is that we can really follow storms. And as soon as something is even organizing, I mean, it's not even a fully formed storm yet, we use the GOES satellite to watch it very, very closely. And that is the best indication that we have in terms of what the track will be and what eventually the intensity will be as it enters our forecast models. So thank you for that. Hope everybody is prepared in Miami and along the coast for what is going to be an active hurricane season. And of course, GOES will be keeping a watchful eye. You can see the imagery from GOES on your evening news, on NOAA web pages. And of course, it will be in our National Weather Service forecast offices where meteorologists will be able to analyze it for those important decisions related to intensity and track. Thank you.
Thanks so much, Jordan. Next one from Meredith Garofalo again. Jagdeep, this might be a fun one for you to take. Meredith asks, any fun facts about GOES-U? How long did it take to build from start to finish? I know it's as big as a small bus, but how heavy is this bad boy?
Yes, so it feels like yesterday, but we were at the GOES-T launch campaign back in late 21, early 22, and we had a small team working GOES-U at the time. And once we launched GOES-T back in March 1st of 22, we came back in full earnest back to Littleton, Colorado, and started up the GOES-U test campaign. So we've been working on GOES-U, doing full environmental testing, vibration, acoustics, thermal vacuum, getting it ready for this launch campaign for the last 2 years or so. And we shipped back in January. So it's been a quick couple of years. Barely feels like any time's passed by. And then, yes, I have the mass numbers as well. We just finished fueling the spacecraft last week, so these are hot off the press. I can tell you that before we fueled the spacecraft was exactly 6,453 pounds. And then after we loaded our hydrazine oxidizer and pressurant, we are now sitting at 10,900 and about 56 pounds. So yes, it's a pretty compact, small spacecraft, bus size, and we're excited to get this off into space.
All right, thanks, Jagdeep. Chris Reith, you may have a little bit to add to that. Is that right?
Sure, thanks, John. From an instrument perspective, there's a lot that goes into the subsystems that make up the instrument. And a lot of these subsystems are very complex and have very long lead times. So as we were talking about with GeoXO and making sure that we have continuity of observations, as we make sure that we're developing these instruments so that we can buy these long lead materials to get them to an assembly point is really important because these instruments can take several years to design and build. And then as Jag talked a little bit about, we have the rigorous environmental testing that goes through at the instrument level and spacecraft level. So staying ahead of the long lead and the very hard to get components is critical for maintaining this constellation.
Great. Thanks, Chris. We have another question. This one, it looks like we'll be back to Elsayed. This is from Lucy Alborg from the AFP News Agency. Actually, two questions, so I'll do one at a time, Elsayed. First one, during the big solar storm that just happened, how would the new compact coronagraph have helped? Would it have provided quicker and more accurate predictions regarding the strength and the timing of the geomagnetic storm, for example?
The answer is yes and yes. It would have. We would have had better specification of the coronal mass ejections that have come off the sun, and those specifications are input into the heliospheric model that propagates the solar wind and these coronal mass ejections towards Earth. So understanding the direction, speed, and size of these explosions off the sun. With a much more sensitive instrument as we are going to have on GOES-U will help us give better predictions.
All right, thank you. And the second part of Lucy's question, and I'm not sure I understand which current capabilities it will replace to monitor the coronal mass ejections. Is it currently done only with coronagraphs on Earth, and why every 8 hours?
So it's currently being done with the ESA NASA SOHO satellite that has the LASCO instrument, the LASCO coronagraph on it. And that it was launched in 1995. It's an aging satellite that's going to be power limited in a year or two. So we are in a race to get this coronagraph up. And the reason why sometimes we have data latency of 8 hours is because of the ground stations that are able to communicate with the SOHO satellite. So we can't control and get the data in as fast as we want. And I will say we have looked at NOAA has looked at adding additional ground capability to get the data faster. But still large gaps can remain in the amount of in the time that between when we get the data.
Great, thanks, Elsayed. Next one, feel free, whoever thinks they could best answer this. This question is from Frank Conkle from GovExec. Any idea how much data GOES-U will produce each day when fully operational? Are we talking terabytes or more? And were any ground station changes needed in order to ingest growing amounts of satellite data?
Dan, Lindsey, I can take that one. So I don't know the exact amount of data per day off the top of my head. I believe it is on the order of a more than a terabyte, say 1, 2, 3 terabytes, something like that. So it is quite a bit of data. It'll be similar to the amount of data produced by GOES 16, 17, and 18, except with the addition of that compact coronagraph, that is an additional data feed that will add some to the total data amount. In terms of the ground system changes, they're really pretty minimal. The only ground system change is we really, of course, need the ability to process that compact coronagraph data that's coming in, since we didn't have that with the original GOES 16, 17, and 18. I will say one thing that we're doing on the ground system side is beginning to test migration of a lot of the capabilities over to the cloud. And the reason we're doing that is it will really increase the data availability and make it more accessible to more users. The work is in progress. It's not there yet, but things are very promising in getting that data moved over to the cloud to make it available to more users.
Great. Thanks so much, Dan. And it appears that was our last question, as we have just a few minutes left. So I will conclude today's media briefing for NOAA's GOES-U launch. I'd like to thank all of our presenters and participants for joining us today. Just a reminder. Oh, do we have one more question? I'm sorry. There we go. I'm sorry, Mike. There we go. Mike Jamilkowski, the Aerospace Corp. This is for Pam. Given the approximate $11 billion life cycle cost, is the GOES-R series worth the investment?
Yeah, thanks for that question. Yeah, we've really looked at a lot of different economic benefits that we get from these satellites. You know, everything from the hurricane warning to the fire benefits to keeping planes away from dangerous volcanic ash to the space weather warnings that we saw in just in the last couple of weeks. You know, the U.S. as well as all of our neighbors throughout the Western Hemisphere benefit from these satellites, and it returns many times over its value to the U.S.
All right. Thanks so much, Pam. We do have just about 3 minutes left. If you have any questions, please feel free to put them in the Q&A box at the bottom of your screen. If we don't have any, I will start to wrap up this media briefing. And I do not see any more coming in, but we do have a thank you from Meredith Garofalo. So thank you, Meredith. Okay, with not looking at any more questions coming in, we're going to conclude the media briefing for NOAA's GOES-U launch. I'd like to thank all of our presenters and participants for joining us today. Just a reminder, everyone, a recording of this media briefing will be available later today at the online media advisory on NOAA.gov, as well as on NOAA Satellite's YouTube channel. If anyone from the media has additional questions or informational needs, please feel free to reach out to John Leslie and myself, John Bateman, at nesdis.pa@noaa.gov. Our contact information is also available in the media advisory. Thanks for joining us.